Hi, let's now continue with Module 5, Impact of Renewables on Electricity Market, and its second block, What impacts wholesale prices? There may be many things that impact wholesale prices. You may think directly of the type of power plants that are out there, your generation mix. If you have more nuclear, wind, solar, coal, gas, etc., this may actually change the supply curves in the market. The technical and operational constraints of your unit may also impact prices. The way the market participants are being strategic or not may also impact prices. So there are many reasons, many aspects to consider. Here we will particularly focus on the weather, since we mentioned in the course introduction that as we go towards more renewable-based energy system, and since the demand is also highly impacted by the weather, then weather might be one of the main drivers that impacts electricity market in the future, and we already see it now. We're going to start with a French example. France decided to invest heavily in nuclear power in the 70s. So since 1974, there has been 63 gigawatts of installed nuclear capacity, that's 58 reactors. Today, there is discussion about the lifetime of these nuclear power plants. Should it be extended? Should these nuclear power plants be decommissioned and recommissioned? Should there be a new generation of nuclear reactors? But still, all in all, it seems that France will remain a nuclear-focused country in the short term. A consequence of the installation of nuclear power plants in France is that it was decided to electrify part of the consumption with particular focus on heating. So recently still, the share of electric heating represented 36% of residential electricity consumption. This is not the case, for instance, if you look at a country like Denmark. Over the last decade, 2001-2011, still for more than half of new residential housing, actually 60%, electric heating was used instead of alternative solution. The reason for electrifying the part of the consumption in view of nuclear installation is that you would like to make sure that the nuclear reactor serve as base load and you don't have to switch them on and off or have them ramping all the time. However, a consequence of electrifying the consumption for heating is that you obviously have your electricity system that is much more sensitive to the weather. And recently, there were numbers that were shared by the energy authorities in France and the system operator. France is actually the most weather-sensitive country when it comes to electricity consumption, and a temperature in winter lowering by 1 degree means that the electricity demand increased by 2.3 gigawatts. You can imagine that we may reach a situation where this can become problematic. For instance, in 2012, there has been a cold wave over Europe with two particular events around the 8th and 9th of February, where the temperatures went down to minus 17 degrees. So on the 8th of February 2012, a first record was established with a demand at the level of 100 gigawatt and 500 megawatt at the end of the afternoon at 7 p.m. The day after, on the 9th of February, this record was beaten and a new record was established with 102 almost gigawatts of demand at the same time. You can imagine that this extreme demand has been driving the electricity prices in the electricity market. And for example, if looking at the prices in the apex, the electricity market in Germany and also active in France, the prices reach 300 euro per megawatt hour on the 6th and 7th, 600 euro per megawatt hour on the 10th, and 2,000 euro per megawatt hour on the 9th. Let me remind you that on average, we see prices of, let's say, 35, 40 euro per megawatt hour in the Scandinavian area for the wholesale market. These price spikes did not always occur for the neighboring countries, for instance Germany, as can be seen from different plots that were released in various reports, where we can compare the prices here in purple for France with the spikes that go extremely high, and here are the prices in black for Germany, where the prices didn't spike. So is it that simple? Temperature drives demand, demand drives the price, and then we get to very high prices. It's actually not that simple. I'm going to use another example related to Christmas period in Denmark, the 25th of December 2012, between 6 and 7 in the morning. We can have access to the data from the Nord Pool, the day-ahead market price, and we see that for this particular hour, all Scandinavia has prices around the system price, so there doesn't seem to be constraints that are active for exchanging electricity, and the price is established at around 33-34 euro per megawatt hour. But if you look at the bottom of this figure, you see Denmark, DK1 and DK2, with prices in these areas at minus 200 euro per megawatt hour, which was the ceiling at the time. So why is that the price was so low? If you look at the exchanges with neighboring country, we can see that the link between Denmark and Norway is congested. It's at 1,000 megawatt here. So you can imagine that maybe it was windy in this area, so there was a lot of wind power production at the time in Denmark, and this was also windy in northern Germany, and northern Germany was trying to also export towards Norway the excess wind power generation. But let's look at that into detail. So consumption patterns first, since we said that maybe temperature was driving demand, demand was driving the price, and in general you would expect demand to drive the price anyway. These are the demand pattern from the day-ahead electricity market for DK West in blue, DK East in red, and overall in black. Remember that the hour we focus on is 6 to 7 in the morning. These demand patterns actually look very normal. There doesn't seem to be an extremely high demand for these days. So could it be that? Or actually, maybe it's on the other way around. Could it be that it's on the production side, and especially related to wind power, since we have so much wind power in Denmark? So let's look at the predicted wind power generation for this same day. Remember that the market was cleared the day before for this day of the 25th. At the time of clearing the market is cleared based on forecast. The bids from the various participants are also coming from forecast. So what was the forecasted wind power generation for that day? These are the predictions between midnight and midnight for DK West in blue, so DK1, DK East in red, so DK2, and Denmark overall here in black. Here is the load, the electricity consumption we saw from before, and you can see that over this period in the morning that covers 6 to 7, there is predicted that will produce more wind power generation than what we have as a load. If you are able to export this wind power generation, this shouldn't really be a problem. But as I explained before, if Germany is also trying to push a lot of energy towards the north, towards Norway, and then the link gets congested between Denmark and Norway, then maybe we cannot get rid of this excess generation, and then the prices drop. All right, so this is what happened. The reason why the price dropped is that there was excess wind power generation, and this could not be exported toward the north. However, when we go through the day and we look at the actual wind power generation, we see that it's not really what happened. In this plot here, from midnight to midnight, we can see again the load reference. So that was the predicted load for the whole country. And what happened is pretty much what was predicted. We see also the wind power forecast that we had from the previous plot. And this is what was really produced in terms of wind energy for that day. So there's a huge difference between the two. There's an error in terms of magnitude, and there's an error in terms of timing with this wind drop. What are the consequences of that? The balancing volume, since we scheduled this generation from the wind, but only this was delivered, the balancing volume was really large, 18,684 megawatt hours. This actually represents 45% of the daily predicted generation here. And roughly, that would be the yearly consumption of 4,000 Danish households. So maybe the problem is related to predictability of wind power generation. Well, we can look at the numbers. There are different ways to evaluate the accuracy of wind power forecasts, which we will study in another module. Two types of scores here, mean absolute error, root mean square error, and they are represented here for the two sides of Denmark. So DK West and DK East are represented with dash curve and dotted curve. And then we have the mean absolute error and the root mean square error, mean absolute error in blue, root mean square error in red. And finally, the bold plane curve is for Denmark overall. So these are some of the numbers one can obtain by getting the data from the Nord pool and calculating some scores for the forecast errors. These are actually good scores. It's quite good forecast accuracy. But still, all in all, we can see over the year, if you were to quantify the amount of energy that is to be balanced from the forecast errors, this would be a huge number that represent roughly the yearly consumption of 300,000 Danish households. So this is a bit cynical that we think we're going to produce a lot of wind power generation sometime, then the prices drop. But eventually this wind energy is not delivered, and then there is a cost for balancing the power system. Thank you for listening. Now I would like to invite you to use the self-assessment quiz to check your understanding.